I'm going to demonstrate how to determine outliers in a multivariate data. A data in which we are simultaneously studying multiple variables or multiple y variables, that is known as the multivariate data. Now let's say if you want to study these 6 variables simultaneously, and if I want to determine outliers, then I have to perform multivariate outlier test. To perform a multivariate outlier test, go to Analyze, and under multivariate methods, choose multivariate option. Now x1 to x6, these are the outcome variables or just the y variables. So I'm going to drag and drop them into this particular dialog box, in the space in the dialog box, and click OK. Now this particular output gives you the correlation matrix. It shows that what is the correlation between the two variables. On the diagonal, the correlation is between the same variables, and on the off diagonal terms, the correlation coefficient is mentioned for each pair of the variable. Now if you click on this red triangle and select second option, which is correlation probability, it conducts a correlation test and tells you whether your correlation is significant or not. So for example, x1 and x5, this correlation is minus 0.0613. So negative means it is in the opposite direction. That means one increases, other decreases. So this is why it is negative. So correlation coefficient is 0.0613, and this is the p-value. And if the p-value is higher than 0.05, that correlation is not statistically significant. Now let's consider this pair x1 and x6. This is plus 0.1943. Now 0.1943 plus correlation means that they are positively correlated. That means if x1 increases, x6 also increases. But this correlation looks like a very low correlation, I mean, because it's very close to 0.2. But if you look at the p-value, the between x1 and x6, it is 0.0058. That means that even though this value is less, this correlation is statistically significant, because p-value is less than 0.05, and wherever the p-value is greater than 0.05, that correlation is not statistically significant. Similarly, we can have a look at another correlation pair, which is x5 and x2. The correlation coefficient is 0.3623 positive, still is kind of lower on the lower side, and the corresponding p-value is less than 0.0001. So it is also statistically significant even though value is less. However, if you look at this particular correlation, which is between x3 and x2, the correlation is plus 0.7433. It's on the higher side, and these two variables are positively correlated. And you look at their p-value, it is less than 0.05. That means they are statistically significant. So this is how we see at the correlation between the variables. Now under this red triangle, click on outlier analysis and select Mahalanobis distances. So Mahalanobis distances is used to check the multivariate outliers. So after clicking on multivariate Mahalanobis distance, one UCL or upper control limit is determined by the software for the given data, which is 3.52 in this particular case. And all the data points which are above this particular line, they are the outliers. And these are the multivariate outliers. These are not the univariate outliers. So in the univariate outlier, one variable would have been selected at once and its outlier would have been removed. But in multivariate outlier, all the variables are simultaneously selected, and through Mahalanobis distance, we see that which variables are outlier, or which data points are outlier in the given data set. Now suppose if you want to remove the outliers, you select all the data points which are above the UCL. If you see that some of the points just lie on the UCL, we can consider them as non-outliers, but all the data points which are above the UCL, I've selected them as consider them as the outlier. They have been highlighted here. They have been also highlighted in this particular sheet. So just right click and click on hide and exclude. Now these data points will not be considered for the analysis whenever you run some analysis in JMP. And that's how you conduct correlation. I mean, that's how you plot the correlation, determine the correlation between the variables in multivariate data, and also perform the outlier test.